Hi all, my name is Goran Vukšić. I'm based in Malmo, Sweden, where I work for a company named Stratitech as technical manager. I'm Microsoft AI MVP, and I'm really a big enthusiast regarding AI and IoT. And today I will show you how I built one interesting project. It is Lego Boost car that, with help of Azure Percept, is capable of doing obstacle detection and avoidance. So what is Azure Percept? How it looks like is you can see over here. In this nice case, there is a career board. You can see some ports over here and that board with two antennas. And also in the kit, you get the smart camera, Azure Vision camera, and you could extend your kit with microphone array that you could see over here. There are microphones on the top, 4 of them. So you could also do some audio detection. So how I started this project and what was the idea? So this is how my project Perceptmobile looks like. It is a Lego Boost car. You can see the base built out of the Lego Boost, and I have the Azure Percept on top with camera sitting on top of it. Why I gave it name Perceptmobile? Because my friend Lego Batman said it is more cool than Batmobile, and yeah, I went with that name. Created the original blog post on Huckster community. This blog post got featured and triggered a lot of interest, so I decided to show you step by step how to build such car. When we take a look at the Lego package, like a standard Boost package comes with four objects that you can build. You can build a guitar, you can build a cat, you can build some kind of machine and car like this. I use this car as a base, but without the front part. So basically, this is how it looked like. You can see it on my camera over here. In the middle there is a Lego smart brick, which is has this one green button you can press, and it will try to connect over the Bluetooth to your computer or your mobile device. The rest is pretty simple. It has motors, and you can see wheels over here on the side. It will turn those motors and move it forward, back, or if it if it turns, that usually you use two motors, both motors going one going forward, the other one going reverse, so it's kind of spinning in the place. This was the base, and on top of that base I placed the Percept, adjusted it a bit, so adjusted a bit this base so it fits, and camera goes on top. Camera connects via USB-C cable to the smart board over here, and you need to plug it into the power. Device is powered with 40 volts. So I haven't built the battery for it, some custom battery. You could even do that, but I try to keep it simple and use the cable to demonstrate how it works. The camera on top is inside of this small frame, which you can easily adjust and put it in some other way. So you could set it to look in front of the vehicle. Lego Boost comes in package with 3 of those small cones, so we will be using those cones to avoid them with our car. So we will do object detection of the cones. I will now connect and turn on the Percept, and we will see how it works. I connected the device, And now I'm in Azure portal in Azure Percept Studio. And over here, you can see my device, which is called SU1, that its status currently is connected. I will click on this device. And you can see over here, I have options to work with vision and speech. I want to work with vision, and I have some actions that I can perform here. Like I can capture images directly from my camera. So I could put my cone in front of camera and take some pictures of it. That pictures will be added to custom vision project. But for purpose of this, I made one custom vision project that you can see over here with approximately 100 pictures with cones in different positions and different backgrounds. I tagged all those cones, and you can see over here we have cone 1 and some cone 2, right? Those cones. So once you manually tag the cones, you can also add more images here. You can train the model, and once model is trained, you can deploy it to Azure Percept. This is done with the Azure Percept Studio, and you have option here, deploy custom vision project. So you say deploy a project, select your project, select the iteration you want to deploy, and click deploy. In a few seconds, model will be deployed to your device. Once model is deployed, you can view device stream by clicking here, View Stream. Your stream is ready, and you would like to see it. So what you see now on the screen is my camera facing the side of my desktop computer, and I will take the cone and place it in front of the camera. And as you can see, detection happens immediately. That is my cone. I could also take another cone and do the same thing, and you see those cones are being detected. So immediately live, you can see what is going on your device, and you can see that your objects that you train model with are detected in this video stream. So we have a model that is on our IoT on edge device, on our Azure Percept, and we have a camera that is capable of figuring out those objects we look for. So what would be the next step? Where we need to, how to actually use this? We would like to access the telemetry of our that is sent to the cloud. And for this purpose, Microsoft has one great quick start example. As you can see over here on the screen, there is a quick start, send telemetry from a device to an IoT hub and read it with a backend application. We will use Node.js, but this quick start is also available in other programming languages. So in order to start using this, we should download sample Node.js project. I downloaded the project and I placed it on desktop in the folder demo. So I will go to that folder on my desktop, and you can see here we have folder Node.js where our files are, and we have a package JSON. So we will first run npm install. This will install all the prerequisites, and in a second we are ready to start working with our code. We will open the read device to cloud messages JS. Now we are in Visual Studio Code, and we can see how this file looks like. So there is a lot of comments at the moment, but code is pretty simple. What we need to do in order to be able to use it, we need to enter the values for endpoint, path, and our key. What happens in the code over here? You can see we have two functions here. One is to log the error message, and the other one is to log the message. When telemetry is received from the JSON, we will log the body properties and system properties. So in our main function here, what happens is that we use this consumer client, subscribe to it, and then we process the event. We print those messages, our function, or we print the error if error happens. In case something is wrong, we have this catch to log the error. There is error with running simple. So first thing we need to do is to enter those three values in the code. In order to do so, we will go to Azure Portal and use Azure CLI. In Azure Portal, we can access the CLI by clicking on this icon on top. It takes few seconds to get connected. And we said we need the values for our endpoint, path, and the key. So in the CLI, I will enter AZ IT Hub show query properties event hub endpoints events endpoint name, and then enter your hub name. So we got the endpoint. Similar thing is for the path. So instead of endpoint, we ask for path value. And the third value we need is our key. So we will write AZ IoT Hub policy show name service query primary key hub name is our hub name. Those are three values that we need to enter to our code in Node.js to get it working. So let's do that. Once we enter the keys in our code, we can run our Node.js and put the cone in front of the camera to see is telemetry being received. So I will, over here, type node and execute our file, read device to cloud message.js. So I started. We see initial message IoT Hub quick start, read device to cloud messages. I use the cone and put it again in front of my camera. And soon we should see over here the telemetry device, telemetry messages that telemetry is received, as you can see, and it is detecting label cone confidence. It is giving you bounding box where this is currently positioned. and what confidence it is. You can see 85, 98, 94%, and so on. So we are successfully detecting our cone and showing it on the screen. I will stop the current script. And now we want this data to expose it locally. And for that purpose, we will use Express. Express is nice little node package which we can install by running npm install express, and it will help us to, once we get this telemetry, we get this detection, this package will help us set the values to show them on our local host on specific ports. So let's get back to the code and edit the code to make this happen. In our code, we will include Express over here, as you can see at the beginning, and we will modify the code a bit. So we will modify our print messages, where we will define one variable. Let's say it is called cone visible, and we say cone is initially not visible. I'm just using string here to make things simple, but you could use Boolean values, and you can also extend this by setting response to actually be a JSON. But to keep things simple, we will just use a string. So cone is not visible, right? Every time when this function is called, and we want to go through our messages received from the backend, and we will check first, is message body length, message body length greater than 0. And for each detection that we have in message body, we will check, is this detection label equals cone and detection confidence is greater than 50%, for example. Depends how your model is trained, you can set this higher or lower. Let's go with 50%. In that case, we will say cone visible is yes. So basically what happens over here, we go through our messages, and for each detected object we check, is that the cone, and we check, is the confidence of detection over 50%, and then we set the cone is visible to yes. Our main function remained the same, but what I added over here is that we define express, and we define some headers that are needed. And on our port 3333, in this case, you can use some other port, but keep in mind that frontend we are using in this example will run on port 3000. So use some other than 3000. We will send our variable, which is yes or no based on detection, to our localhost port 3333. Okay, we can save this and we can run it, and we can have we have the functional backend on our computer that is reading this telemetry and showing yes or no on the localhost. Now we would like to connect to our Boost device. And for that purpose, we will use the Lego Boost app that you can find on the GitHub. And that application is really nice because it's a React app that gives you some kind of manual control and gives you a lot of options to communicate with your Boost device. Communication is done via the Bluetooth, and you can write even some code over here to communicate with the Lego Boost. Writing whole protocol by yourself, doing everything via the Bluetooth is kind of hard. So we will use this nice application to communicate with our Boost device. And you can make a Git clone of this repository, run npm install, and run npm start. When you do it, you will see application popping up on your localhost 3000. Now I will take my Lego Boost device in the hand, and over here you can see you have an option connect. So when we click connect over here, Web Bluetooth will try to connect to Lego Boost, which means we need to press this green button on the Lego Boost, right? We press the button here, we click connect, and the device will be paired. Once it's connected, the light turns green, as you can see over here. So let's explore our application a bit. What we have over here? We have a manual control, for example. So let's switch to that, and we are connected through browser to our Lego Boost car. I'll make it a bit bigger. So if I press forward, you can see it's running, right? So I press stop now to make it stop. We said we also have the code editor. So let's take a look how that looks like. We go into the code editor, and over here we can write some commands. I'll start with, for example, I can say, let's turn this LED over here that is currently white, so it's not really visible. Let's turn it, for example, to red. I click execute on this code, and you should be able to see it went to red. The same way I can turn it into other colors, but I can also make it move. For example, I can say boost drive 30. 30 is some value for the distance that boost is measuring. So when I say execute on this, let me just show you the code for a second. You can see boost drive 30. So switching back to camera, I just click execute over here, and you can see boost is driving, right? So we can drive. Let's see this code example I prepared for our boost to be able to communicate with our backend. I'll uncomment the code, and what we have over here, is we are making one simple request to our backend, which is running on localhost port 3333, right? And we are checking is this request status was okay, and then checking what data came back. If it's yes, we could turn the LED red. In other case, we would turn it green, which means if our Azure Percept device is detecting currently that there is a cone in front, and we can see over here our localhost, which is displaying no at the moment. So that's the current value that is displayed. We could so that means car is not blocked. So car could move forward, right? In that case. And if car is blocked, it could turn light red, but it could also turn the boost for certain number of degrees. So the way I made it is that once cone is detected, boost will rotate for 30 degrees and tries to continue if there is no code. So our local backend is constantly checked for the values, and we in the code over here decide what we want to do. If car is not blocked at the moment, it will move forward, and if it is blocked, then it will turn 30 degrees and try to continue if it's not blocked anymore. So in the following video, you can see a small demo how it worked, and also demo with the cone detection in front of the car. Thank you very much for watching this video. I hope you learned something new. As you could see, this Azure Percept device is super simple to use, and really gives a lot of possibilities to do AI on the edge. And I hope this inspired you to build some kind of your own project, and please share it with community once you do so we can also learn something from that. Thank you for watching.